Well, first of all, okay. So, all right, we have made it through the first project, and yeah, this the first three lessons that we're going over are a little more kind of computer science fundamental focused. So we're focusing a little more on some advanced fundamentals in JavaScript, which is what we covered over the last 3 days. So we did that with closure and recursion. And again, recursion's a principle that spreads across many computer programming languages. But yeah, we covered recursion. We covered closure. We covered this keyword. Arrays and objects, callback functions. Pretty much every advanced topic that you would need to know in JavaScript to function well as an engineer and to do well in a job has been covered over this last project. Maybe not in super deep. Maybe there's not a million problems in there to help you totally master recursion, but we've touched on pretty much all the things that you'll need to know and master over the next 13 weeks. So we're going to keep reiterating on those things, and by the end of the class, recursion and closure and all those things will be very natural, and you'll just understand those really well. So again, don't feel bad if you feel like you're drowning a little bit. It's kind of where we want you to be. So all right, so today we are diving into data structures and algorithms. Data structures. Okay, so we're doing data structures, and what a data structure is you can kind of think of it as a way to kind of work with your data inside of your program. It's a way to handle all the data that comes into your program and the data that you're working with. So there's two primary data structures that are used all the time in JavaScript, and the terminology will be a little bit different across multiple languages, but within JavaScript, the two primary data structures that we work with are arrays and objects. So our arrays, it's an ordered list of whatever we want to put in there. In some languages inside of arrays, they have a very fixed length. They're not. It's not easy to expand and change their size or reduce their size. They'll have multiple data structures to handle that. In JavaScript, we have this nice array that can just dynamically expand and contract based on the content we put in there. It can have mixed data types in there. What that means is you could have a function, you could have a Boolean value, you could have a number, you could have a string, all inside of the same array. In many other languages, that's impossible. You can't do that. It will break. There will be errors if you try to put different types inside of the same array. So in JavaScript, you're kind of handicapped a little bit because you come in and when you're trying to learn these other common data structures that get asked about in interviews and in our these fundamental CS principles, you kind of miss them when you're programming in JavaScript because we have like our array is kind of 5 or 6 different data structures that from other languages that are all squished together. So so today we're going to learn about some of these other really common types of data structures. Over today and tomorrow, there are 7 data structures that we'll be covering, and it's in a way you're kind of you'll be reinventing the wheel over over the next these next 2 projects. These things are already implemented in JavaScript below the hood, but then now we are going to impose some self-instructions on what we can and can't do with objects and arrays, and we're going to kind of use them to model and build out these other common data structures. And so there's a lot of benefit that will come from that. But it'll make you guys better programmers. It will help you to understand these different design patterns, and they're a lot of fun. They're a lot of fun to play with. So Yeah, just real quick. So like arrays, what we call an array in JavaScript is almost kind of a blending of a hash table. In one sense, it's kind of like a linked list. In another sense, another language might call it a vector. It could also, be an array. There's different kinds of arrays. But we're going to be using arrays to build out stacks and queues. Those are the first basic data structures we're going to talk about. And then we're going to go into linked lists, and then we're going to cover hash tables. Hash tables and objects in JavaScript are, that's what objects are in JavaScript. An object is essentially a hash table. And so we're going to talk about, those 4 different types of data structures. So, all right, let's jump in and do a screen share. Let me just clean up my computer a little bit. All right. Okay, so the first thing that we want to talk about is it's called Big O notation. And if I type in Big O notation cheat sheet, then that should pull up this nice little graph that I want to show. All right. Okay, so we're going to talk about this a little bit right now. We're not going to go very deep into it, but this is just kind of a gentle introduction into this concept, so you can kind of start to think about this with when you're writing your code and when you're writing out algorithms and solving puzzles. So, what Big O complexity is it's kind of a generic way of tracking how well a function or some code and algorithm, those are all kind of, I'm saying the same thing when I use those different terms. So like an algorithm, a set of instructions. Big O complexity is a way to measure how well it scales. So let's say we wrote a function that's 10 lines long. It doesn't matter what it's doing right now, but we have a function that's 10 lines long. How long does it take if we pass in an array of 100 items? If we pass in an array of 200 items, does it take twice as long? Does it take 10 times as long? Does it only take like half again as long? Or does it run in the exact same amount of time? So complexity, it's a way of measuring how well your algorithm works on larger and larger and larger pieces of data. So we're going to explore just some of the basics of that. So if we have a function, we're going to call it looper. And all looper does is it takes in an array, and then inside of it, we're just going to go array.forEach, and then we're going to go, let's go item, we're going to go console.log item. I'm breaking this out on the multiple lines for readability. All right, so then if we go, const array is equal to 1, 2, 3. And if we go looper array, pass that in, and I've put pictures. Okay, so we see 1, 2, 3 prints out. So all we have here is we have an array, we have a function, we pass the array into the function, and then it iterates through and prints it out 1, 2, 3. So with this function, if we look at it, we just iterate over the list of items and we print them out. If I double the size of the array, just because it's doing a simple loop over the array, it's only going to take about twice as long, about twice as many operations are executed on this array. If I add 3 more to it, then there's 3 times as many operations as when there were only 3. So it just, just a simple loop. As the input size increases, the number of loops that it has to do increases at the same pace. If there's 100 items in this array, there's going to be 100 iterations inside of the loop. We call this linear complexity. So if we come back here and look at this, let me find a different chart actually. Let's see. There was a good one. Yeah, this is the one I usually. Oh, this is one here. This is one I usually like to pull up. Okay. So we see there's a couple of these little, these little like, you see like an O and then a 1, an O, and then log n, O and the square root of n, O of n squared, O of n cubed, O of n to the nth. So these are all just general types of complexity that an algorithm have. These are the most common types. So right here we have linear. So with linear, it's just saying that as our input increases, so the array that's coming into the function, as we double it, the function is going to take twice as long. If we double it again, it will take twice as long again. If we double it again, it'll take twice as long after that. So it's linear. It increases at a straight line. So that's just like a for loop. A for loop would be increasing linearly like that. All right. So if we were to go and, and actually, sorry, actually I think I like, I think I like this one a little better. Sorry to jump around on that. Okay, just because the way that it showed the beginning of that chart, I didn't like that very much. So, all right, so the green right here, linearly, the time increases as the number of elements in the array increases, the number of operations that are run increase as the input size increases. All right, let's all, okay, I'm gonna walk through another example, and then we're gonna do a Socrative poll so I can see, how you guys are doing. So I'm going to do a plain for loop now. I'm just going to go for let I get 0, I less than array dot length I plus plus. All right, then inside of here I'm going to go for let I get 0. Oh, I'm sorry, not I. I'm going to go j gets 0, j less than array dot length j plus plus. All right, and then inside of here, I'm going to go console.log ij. All right, so actually, let's I'm going to make this a string so that way they'll sit together. All right, so if we run this on 3 items, all right, so if we run that, you see here, there's 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. So even with 3 items here, it had to go 1, 2, 3, 4, 5, 6, 7, 8, 9. There were 9 operations that ran on 3 items. So because this array is 3, and so this first cycle of the loop, in order for the first iteration of the loop to finish, this inside loop has to run 3 times. So before I can even get onto the second loop, this inner one has to run 3 times. So it goes, for the 3 times that this runs, it's also running 3 times in here. As we increase this to 4, we run this. You see how many printed out. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So if you've noticed the pattern, we're essentially squaring the input. As 4, we square it, it took 16 operations. With 3, it took 9 operations. If we did 2, it'd be 4 operations. So you see that compared to our first looper function, that when we put in 3, it would just print out 3 items. When we put in 6, it would print out 6 items. Yep. All right. And David is catching on. Yep, got it. I'm sure you had to study that a lot in school. So, yeah. So the notation for this one is we refer to it as this is a good little cheat sheet. I can pull it up for you. This breaks down a lot more of the. Don't be intimidated by all the math that you see in here, but this breaks down a lot more. It goes in a little more detail some of the different types that you see. But yeah, we call this quadratic, and so O of n squared. So you see that it's as the input size increases, it's essentially squaring how long it's going to take. All right. So then if I go clear and run that again, see anyway, it takes much longer. So like 100 items in this array is going to take a lot longer than 100 items going through a linear algorithm. So nested for loops, just rule of thumb, if you have two loops inside of each other, that's quadratic complexity. That's O n squared. If you have a single for loop, that's linear. So let's look at, we're just doing 3 basic examples today. We'll touch on some additional examples later on, and expand on it a little more, but right now we're just going to keep it pretty basic. So right now, if we did return array sub 0. Yep. So if we just access the first item of the array and immediately return it, let's log it out. When you run our code, you see 1 prints out. If I add 10, 11, 12, 13 onto it, just 1 prints out. There's 1 operation. This is called constant time. So it's O of 1. It means that it doesn't matter how big the input is. The input could be a million bajillion things long. It's going to take like the exact same time in order to order the way that this scales. It's not going to take any longer if the input size increases. So if we go back and look at our chart, constant time is this. Well, that's O log of n. It doesn't even have constant time. You can't even really see it, but it's just like down there on the bottom. If we look at this one, constant time is this just straight blue line on the bottom because it never rises off the bottom because it always takes the exact same amount of time to complete regardless of how large the input is. So on an object, something that's kind of cool is if we want to retrieve an item out of an object, if we want to, if we have, const object and set it like this, and if we go x is 5, one advantage to objects is if we know the key, then it's constant time lookup. We instantly can grab the value out of it. With arrays, we often have to search through them. We have to loop through them. And that takes longer, and that has a worse complexity. So anyway, so you want to kind of start to think in those terms a little bit. Yeah. So don't. Anyway, so yeah, so we're just talking about linear, constant time, and then quadratic. Those are the 3 examples we're covering today. We'll go over some of these other ones like logarithmic time and factorial, some other ones like that in future lessons. All right. So now I want you guys all to jump in. I want you guys all to go to Socrative. Awesome. David used to teach this in a computer science class. So David has actually had a lot of experience teaching programming. So he's really knows his stuff. It's great having him here in the class and having all of his all that knowledge and experience. So he's here so I can try to teach him some of the current web development standards. So there's a lot of wisdom there. So all right, so if everyone goes and jumps in that Lambda School classroom, if you need a reminder, it's called Socrative.com. and then the room name is Lambda School. So, all right, first question. Give me an A, B, C, D, E. A is if you feel like, how you're feeling about just those three basic big O notation, the complexity analysis in general. Just how are you feeling about this? A, like, oh my gosh, move on already. E, like, I have no idea what you just said. So, great. All right. Awesome. All right. Everyone's following along really well. All right. So now let's let me give you guys a little quiz. All right. So if I have const foo and I set this equal to a arrow function like this, and inside of here I go for let I get 0, I less than array dot length, and I'm going to go and add that parameter up in just a second. So if I have array in here, then I'm going to go console.log array sub or bracket I. Okay. So I'm going to go foo 1, 2, 3, 4, 5. All right. Turn that out. All right. Is this constant time, linear time, or quadratic time? And so we'll do A, C, and E. All right. So answer in here what you think it is. A, C, or E. Is this constant time, linear time, or quadratic time? So again, constant time is O of 1. Linear time is O of n. Quadratic time is O of n squared. All right. Awesome, 100%. Everyone got it right. Okay. All right, so now let's all right, let's do this. For let j get 0, j less than array dot length, j plus plus. All right. And it doesn't even matter what we're printing out here, but all right. What is this? Is this A, C, or E? Constant time, linear time, or quadratic time? Every time I say A, C, or E, my phone goes off because it thinks I'm saying Hey Siri. All right. Great, 100% again. I think you guys got this. All right, so the final question. All right. Okay, what is this? A, C, or E? Just went off again. Great, okay. All right, you guys got it. So we're just starting out with those basic ones. We'll go into some of the other ones later on in the course. But yeah, so start to think about this when you're writing your code. Think like, oh, the way I'm writing this is going to be quadratic. This isn't going to scale very well. This would be, in a production application with potentially tons of data. Like on a server that maybe it's handling massive inputs. This would be terribly inefficient. So how could I get this closer towards linear time, or how could I do better than linear time? How could I get it down to logarithmic time? And so we'll go into more of that and analyze that a little bit more another day. So all right, so now we're going to get into data structures. So the first data structure that we're going to talk about is called a stack. All right, so what is a stack? How do we think of a stack? I want you to think of a stack of pancakes. So here's a great stack of pancakes right here. So the first pancake you put on the plate is the last one that's going to get eaten. So we put all these pancakes on the plate, and then the first one we want to when we want to get a pancake, we take one off the top. We can't access the ones on the bottom. I mean, you could. It would be kind of a pain, but we're going to pretend in this magical world that you cannot get the pancake on the bottom no matter what. So you put the pancakes, you stack them up, and then you take them right off the top. So if you want to get to the one on the very bottom, you have to take all the ones off that are on the top. You could think of it as a stack of plates. So if you want to get your plate that's on the bottom, you got to take all the ones off the top. So the first plate that you put down is the last one that you would access. Okay, so this is how a stack data structure is. This is like what a stack data structure is like in programming. Let me show you a. There's another good picture. Yep, that's the one I wanted. So, all right. So a stack data structure is it's a place that you're holding some data. So maybe these are just numbers. Maybe these are or let's say they're strings. It's the birthdays of all the people, and so you add all these different strings onto here on the stack, and then when you want to get one, you take one off the top. A practical example of when a stack is implemented, think about your back button in the browser. So when I hit the back button, it's going to take me back to the most recent page that I was on. If I hit it again, it goes to the next most recent page. So if we think of a stack in terms of code, let's go const stack, and I'm going to write it as an array. Let's say I go to, I'm at google.com, and then, or let's say that, okay, so I'm on the page. I click a button to go to Google, or I'm on google.com, and I start to go to Facebook. So then this stack, or this little history thing, is going to say google.com, and now I'm on Facebook. Let's say I go from Facebook to Amazon. So now it's going to say facebook.com, and I'm on Amazon right now. Let's say I go from Amazon to Netflix. So now it's going to say amazon.com. So with the stack, the items in the front are not the ones we're going to access. We're going to access the ones starting from the back, the end of the stack. So we put them on the end like that, and then we're taking them off. So you kind of think of this as like an upside down plate right now. We're sticking the things to the ceiling, and then we're peeling them off from the bottom. So let's say I'm on Netflix, and then I hit the back button to go to Amazon. We go back to our stack, and then we pop off the top, and then now we're on Amazon.com. And then if I hit the back button again, it's going to go back, and we're going to pop off Facebook.com and take us to Facebook.com. And now there's only one item left in our little short history. So if I hit the back button a final time, it's going to pop off Google.com, and it's going to take me to Google.com. So that's like one way that you could think of a stack. There's also the call stack, the way that functions open up. If you remember with recursion, when a function calls itself, the bottom one is still open, and you have all these functions opening on top of it. It's like a stack, and then it has to wait for that top function to finish before it can close up the bottom ones. So it's like building up this stack of pancakes, and then we eat it down to the bottom again. So high level, that's what a Canada. So that's so basic high level, that's what a stack is. All right, so the next one that we're going to talk about is called a queue. A queue. So with a queue data structure, it's a little different. So instead of putting things on the top and then taking them off the bottom, and the name kind of hints at it. It's you put something in line in the queue, and the first item that's put in the queue is the first one to get out. This is like a line for a roller coaster at Disneyland. So the first person who gets in line to get on the roller coaster is the first one who's going to go and get on the roller coaster. If you're in a line to get some ice cream, the first person is the one who's going to go and get ice cream first. In code, if I were to make a help queue, so if you guys needed to get help from me, if I had a little thing where you could push a button and request help, that we would use a queue. And the first item that gets put into that queue is the first person that I would help. And then when I'm done helping them, that item would be dequeued or removed from the queue, and then I would go to the next item that's at the front of the queue. So this is a queue. It's called first in, first out, and you'll see these two terms thrown around. So a queue is FIFO or first in, first out, and then a stack is LIFO, or last in, first out. So yeah, so queues, stacks, they're pretty basic. In the project that's coming up, you're going to use an ES6 class to create a stack, and you're going to create a queue, you're going to create a linked list, and you're going to create a hash table. So to create these behind the scenes with a stack and a queue, you're going to use an array. With a queue, like for an array, to make it function like a queue, you just go array.push. That puts it into the array, and then to take something off the front of the array, we go array.shift, and so that pops the item off the front. So if I go A, and then let's go B, C, and then let's go const first is equal to that. Then we it's const.log array and first. Then what you'll see is we have A, B, C, and then A was popped off. It was DQ'd, and B and C are still in line. So it's we add items to the back, and then we take them off the front. The stack is the opposite way. We add the items in, and then we take them all out in the same, or in the opposite order that they were put in. The newest item is the first one that's going to get taken off. So you'll use arrays behind the scenes to create the stacks and queues. So again, you have a class. There's some different methods that you're going to define on the classes, and then and then the tests behind the scenes will call those methods to add items to the queue and remove them, and things like that. All right. So now let's talk about hash tables. So a hash table, and let's see, there's a good picture. I want to show you guys. This one, I like this one. All right. Okay. So this is what a hash table kind of looks like. Objects in JavaScript are essentially hash tables. So the way a hash table works is a hash table has to have unique keys. And there's a unique key associated with a value. The cool thing about a hash table is if you give it that unique key, the hash table in constant time, it immediately gives you the stored value. With an array, you might have to iterate and search through and go and find it, but it's this key value pair, and the hash function, this is kind of behind the scenes how your objects are working. So the way that the hash function works is it takes in a string. Then there's this so a hash table, sorry. So this is the hash table, and the hash table has a hash function. The hash function is why they call it a hash table. So there's a hash function, and then there's these buckets, or the table. These are all the little slots that all the data is going to be stored in. So this array, or this data that we have inside of the application and inside of your homework, there's a helper library that makes a special array for you that has a limited length, and it's empty. So it will start out with 8 slots in it, and they're all empty. And then what happens is you'll pass a string into a hash function, and then that hash function will do some magic with the string, and it will return an index for that array. So when we pass in John Smith, this hash function will magically determine an index between 0 and, in this example it's 15. In the homework we start with 0 to 8. But so we pass in John Smith, this string gets magically run through this little function thing, and then it spits out the number 2. And if we put John Smith into this hash function, every single time it goes in, it's going to spit out a number 2. It's kind of like when you're a little kid and you had like secret messages that you would encode, and you would if you passed in the string, it would come out as a couple like a word, it would come out to the exact this same code, like it kind of scrambles it. It's kind of like what this is doing, but instead of it scrambling it out into this big long like code, it's scrambling it into a number. It's using this unique string to somehow determine a number or an index where that information will be stored. So right here, this is like a phone number. So the key and the value pair, the key is John Smith, the value is the phone number. We pass in the key, which is a string. The hash function does some magic, and it spits out 2, that index. And so it saves his phone number at that index. And now, in the future, if we wanted to get John Smith's phone number, we just pass in the string John Smith, and the hash function knows that when it sees this string, it computes the number 2. We could pass in John Smith in 10 million times in a row, and the hash function will always compute a 2. And so it maps this string to a slot in this table. And so it says the same thing with Lisa Smith. This string is different. And so you don't have to care how the hash function does it. The hash function just takes in a string, does some magic, and it essentially turns Lisa Smith into a number, an address. And so then we go to the 1 slot, it saves in the value right there. Sandra D, the same thing. We come in, the hash table does some magic, and we get to 14, and it saves your number in right there. Okay? So the key here is this table will start out at a fixed length, and it will all be empty. What will generally happen inside of a hash table is, and this is an extra credit problem, is once the hash table is about 75% full, then this table here will double in size, and then all of these different values will then be repassed through, or they'll be it can do like a resorting. And so what will happen is, so the table will double in size, and then so it can handle new keys that are coming in. And so that's generally what will happen. And one of the extra credit problems in the assignment, as the hash table reaches 75% capacity, then you're going to double the size of this storage unit, which will be a special array that you'll have, and then you'll store the items in there. If there's a conflict, because sometimes you can have 2 different strings, especially if this is only 15 long, there's an infinite number of combinations of strings you could get. Sometimes there are conflicts. And so different ways to handle them. The way that you're going to handle conflicts is if there's let's say Lisa Smith and John Smith both mapped to 1, this first spot, then what you would do is you're going to create an array here, and you're going to store 2 key value pairs in this slot. And that's just the way that we're going to approach it and handle it within our homework assignment. But I realize that might be a little low level right now, but anyway, you can come back, rewatch this later, ask questions, and we'll help you work through it. But these are the basics of a hash table. In JavaScript, an object is a hash table. So if I go const object, and if I go object and then x, set it equal to 5, then when I go if I go console.log and I go object.x, and it prints out 5. So what this is doing here, and again, on an object, every single key you put on there, even if we put like a number, that number gets transformed into a string behind the scenes. We can't access it with .x because I changed it to not be x, but all of the properties on an object, they're all strings. They're always strings. If they start out as something else, they are converted into a string. So if I put true like that, I can actually go object.true because it's converted into a string. It's not a Boolean value. It's it turns it into the string true. Okay, so yeah, that's what's happening when I make a key on this object. This string right here is going through a hash function, getting mapped out to a spot in memory, and then it's saving this 5 at that spot. And then we come down here, I'm saying object.x, I'm saying here's the x key, and so it passes it through the hash function that spits out some weird memory address, for the location where that information, that data is going to be saved, and then it's going to go retrieve it and grab it and bring it back to me. So this is a very, very fast retrieval. If we have the key, we can instantly retrieve the value. That's the advantage to a hash table like this. So, all right. Okay. Objects. All right, so let's go back to Socrative real quick. Let me see, A, B, C, D, E, how do you feel about the theory of a hash table, just kind of high level, what it's doing? All right, okay, good, good, okay, all right, this is good. So again, in terms of JavaScript, what you could kind of think of is if we had a const hash function, and this takes in a string, and this is going to return, like it'll return some random number. We'll just say that like it's 5, but then like ignore the inside of this. So what would happen is we have our this like array, and so then what would happen is our const hash table, it takes in a key and a value, and then what we'll do is we'll say our index is hash function key, and so then just ignore what's in here, ignore that it's just returning a 5. Imagine that as the key changes, it's going to return something new each time. So we have our index that gets back, and then we're going to say storage index is equal to the value. So what would happen is we would say, this is like just specifically adding it to it, but then if we did, hash table, and then we did a, let's say the key will be name, and the value will be Ben, and then we'll go console.log storage. All right, so we clear this, we run that. Let's see, initializer and const declaration. I wrote a weird function again. Okay. I was just writing some ES5 functions for a hoisting lecture, and all right, okay. So you see here that in JavaScript, this is kind of weird how it handles it. So it just, if we put something in at index 5, it automatically fills in all the previous indexes with undefined. But you see here that name came into the hash function, it spat out an index, and then storage index value, it saves it into the function. So I don't know. Sometimes seeing the code can kind of help. Sometimes this kind of confuses people. But again, just high level, the string comes in, hash function spits out an index, you save the value at that index. If we pass in John Smith to get a value, this hash function will always spit out a 2. And so we get the 2, we grab the data, and then return it back. Okay, so that is a hash table. All right. Does anyone have any questions about hash tables? All right. So the next item that we're going to go over is it's called a linked list. So a linked list is it's a bunch of separate little nodes that are all connected together. It's one of the advantages to it over an array is that it's easy to add items onto it. It's easy to add items into the middle. In the traditional sense of an array, it's in other languages it's difficult to add items into the middle of an array. It's difficult to add items on the end of it because you have to just the everything that's involved with you have to shift all the items over. Because in an array, if you stick something right in the middle of it, all the items that come after it have to all be shifted over one index. And so, but with a linked list, it makes it really easy to insert items right into the middle. So, where'd my picture go? Maybe that's what I searched. Yep, here we go. That's the picture I like. Okay. All right. So in JavaScript, we don't use linked lists because our arrays, they kind of cover the functionality of a linked list. They're very convenient. They kind of handle, They kind of do all the things. Surprisingly enough, in array in JavaScript, it's it's a stack, it's a queue, it's a linked list, and it's a hash table, because everything in JavaScript is an object. Because arrays are it's actually just key value pairs with numbers and then values. But if that confused you, forget it. If that made sense to you, then great. So don't worry about that part though. So all right, here's what a linked list looks like. You have so think of it like you have these little rectangles. This left square is the value. So right here we have a list of numbers. This is a linked list of numbers. And so right here we have a 12. And then the second slot is an address. It points to where the next item in the list is. And so we have this list right here, or we have this item right here. So a 12, and then it points over to here. We have a 99, and then this would point on to the next item. It makes it really easy to add things in the middle because we don't have to shift things in memory. But again, we haven't really, we haven't done a deep dive into those concepts yet. Don't worry about it as much. So essentially, the way we add an item to the middle of a linked list is we just switch where these memory pointers are. We just take our new item, and then we have this item right here points to the new one, and then the new one points to the one that was originally next in line. So it kind of fits in the middle there. So and so it's funny. I mean, we never really use linked lists in JavaScript. But I actually had to code out a JavaScript implementation for a linked list at an Amazon on-site interview in Seattle. This last summer, I flew out to Seattle. I was considering taking up a job at Amazon, and they had me write out a linked list in JavaScript. Ended up not taking the job. Now I'm doing this, but. So this is you'll get asked about these kinds of things if you want to get a job at at a major tech company like Google or Facebook, places like that. They're going to ask you about these data structures. They're going to ask you about complexity analysis. We're introducing these things to you early on because our hope is that we can work on them over the next 13 weeks and get them to where you're very comfortable with these concepts. Because the harder we are with you right now, or the more difficult within reason that we can make this, the higher level we can hopefully help you attain. So we don't want to bury anyone, and we're going to work with you to help you help you succeed. But we are trying to move pretty fast. So all right, so there's this is kind of Amazon has thousands of openings. Same with Google and Facebook and all those companies. They there's a high standard, to reach to get companies or to get jobs at those places, but there is so much demand right now, and it's only growing. There are more and more tech companies appearing. You have to reach the standard, but they're still anticipating that the demand for programmers is outpacing how fast universities are producing them. That's why boot camps exist, because universities haven't been able to increase their output, and these massive tech companies they need programmers, and so that's why we can exist, because we can come in here, we can teach you these fundamentals, teach you how to actually code and build stuff, and if you work hard and if you can reach that standard, then you can find a job. So so it's a pretty amazing time right now if you're trying to get into tech, because it's I don't have a bachelor's degree, and yet none of these companies bat an eye at that. It's not even I've never been asked about it. Well, I get asked about it occasionally, but then they're always very quick to clarify that it doesn't disqualify me. They're just curious if I finished or not. And so I have a friend who was a high school teacher, and anyway, now he's works for Apple as an iOS developer. It doesn't matter what your background is. If you can learn this stuff, you can succeed. So, but you have to learn your data structures. You have to learn your complexity analysis. You have to, learn recursion. You got to learn closure. You got to learn all these things that are hard. We're going to do the best to help you learn them. But these are the things you got to learn if you want to, have a successful career and be able to get your foot in the door. All right. So hash table, linked list. The way that you'll structure the linked list in your application that you're building is you'll have nodes. So you'll have like node 1, and it'll be an object, and then you'll have the value on it. So let's say this is 5, and then you'll have a next property on it. And the next property will say like node 2, and then you'll have const node 2, which will be value 10, next node 3. And right here we'll go const node 3 is equal to value 15, next, and then we'll say null because this one's at the end of the list. So high level, this is kind of how you're going to be structuring it using objects like this, but then it'll be kind of interesting because the way you'll add them, the class, you're only going to have a reference to the head and to the tail. You'll only have a reference to the first item and then the last item. And then the rest of them are all going to be kind of these references held in memory. It's essentially be nested. You can kind of think of them as being nested inside of each other. And yeah, so with a linked list, you'll have to iterate through it because you'll just have the head, and so you'll have to iterate through. This is a singly linked list. So right here we have a singly linked list that points in one direction. Sometimes they have what's called a doubly linked list, and so if we look at a diagram of that, yeah, so here's an example. So here's our so this is like, the head, the next one, we have the tail, and then we have a doubly linked list where they'll actually, an item will point to the one before and then will point to the one backwards. So there's, different challenges associated with each one, different benefits, different trade-offs, but we're just focusing on a singly linked list. We'll give you some coding challenges surrounding doubly linked lists later in the course. But right now we're just focusing on a singly linked list. So for our JavaScript implementation, again, just remember we are reinventing the wheel. We are building a linked list with a high level, it's kind of a weird implementation we're doing from this for actually we wouldn't probably go plug this into a real application and use this, but. This is just so you can learn the concepts, understand how this works, and then, then this will also benefit you too as well later on if you start to learn another programming language. So, all right, stacks, queues, linked lists, and hash tables. Those are the 4 things we're going to work on today. The next project we're going to go over trees, binary search trees, and graphs. Those will be the 3 that we're going to cover for the next project. So those are the 7 data structures that we're going to hit. Then after that, we'll be jumping into React. All right. Any additional questions? Any other questions? Okay. All right. Yeah, this one will be fun. I'm going to I'll be sending out your partnerships in just a moment. The way that I would like your pair programming to work is I would like you to, in your pair, to open up a Google Hangout, and then what will happen is you'll both get in there. You'll both be working on the same project, and we just want you to collaborate and work together on the project. We are working on testing out some different tools that we are going to use where in the future what will happen is we'll actually, when you do your pair programming, we'll have you actually one of you will be typing, and the other one will be, you'll both be modifying the exact same document. And so we have some tools that you can plug into your editors that link them. Flubits is what we're looking into, that's what it's called. So it'll allow you both to be editing the exact same document. Kind of crazy, but for right now, the way that pair programming will work is you guys will take turns. One of you will do a screen share, and that one will be writing the code. And so when you're writing the code, you're the one that's it's like you're driving the car, and then the other programmer, his or her job is to be the navigator. And so, so for example, if I'm in here, typing the code, I'm going along and writing it, my navigator would be looking at my code, scanning for typos, making sure that I'm writing it the right way, and then my partner, she would also be giving me kind of feedback or helping me walk through the steps that we've discussed. So the person who's coding is, you're kind of the scribe, and then the person who's watching is the one that's kind of, controlling the direction of the coding. And so the point is, you guys can have a discussion, figure out how to best solve the problem. The people in our class, you're all at different levels, and so there's, you're just going to have to, you'd be working with people that are, more experienced than you. You'll be working with people that are less experienced with you. So what we're doing is this is just an opportunity for you to be able to get to know the people on your team better, and I do think that this will help increase the increase your learning rate. So everyone who is in here, who is in the part-time class, will you please send me a direct message? Just say hello. I just want you to send hello. All right. Just because we have a couple people that, for work and different reasons, I know some people that they actually watch our lectures in the morning and work in the class because they have to work in the evening, some stuff like that. So I need to make sure that I know who is here right now, and then this is what we're going to base the pairs off of. Okay. All right. Sounds good. All right. So I will see a chat. Oh, hello. All right. Okay. Great. All right. So I'm going to go through and I will start. I'll pair you guys up, and then I'll post the link to the repo. If you want to just go and dive in right now, it's on my GitHub. It's called LS Data Structures 1. So if you go in there, that's where the project's at. But yeah, this is what we're going to work on tonight, and then we'll work on it on Saturday. At the end of the day, Saturday, we'll go over the solution. All right. Good job, everyone. I'll be messaging you, and then I'll be on call for questions. Thanks.